Here we have a problem on solving exponential equation. So there is an exponential equation given over here. In this exponential equation, we have to find the value of x. Okay, let me write the given exponential equation as it is. That is 3x positive 6 root of 9 to the power of x positive 5 equals to 4th root of 81. Okay, before I start solving this question, let's understand some stuff on radicals. That is, consider square root of x. Okay, so here we have square root of x. Square root can also be called as radical. Okay, if I want to change the square root as an exponent for this stuff inside the square root, what do we have to do? So whenever I want to write the square root as an exponent, then the exponent will be 1/2. Okay, so what if I have a cube root of x? Then it will be x to the power of 1/3. So whenever I want to change the radical as an exponent, what I have to do is, so I have to write a fraction the exponent with numerator 1. So what should be the denominator? The denominator has to be the index of the radical. So what is the index of this radical? It's a square root, its index is always 2. So I'm writing the index of the radical in denominator over here. So here also we have radical. So I'm writing the exponent as a fraction with numerator 1. So the denominator has to be index of the radical, which is 3. Okay, what if I have nth root of x? So again, x, and we have to write a fraction as an exponent with numerator 1. And the denominator has to be the index of the radical, that is n. So the same concept I am going to apply in our problem. So here we have a radical sign, and the index of the radical is over here is 3x positive 6. Okay, then we have 9 to the power of x positive 5. And if I want to write this radical as an exponent, it has to be 1 over, the denominator has to be the index of the radical, which is 3x positive 6. Okay, now I can do the same thing over here. So here we have a radical, so we can write this radical as an exponent, then we get 1 over, so the index of the radical, which is 4. Okay, now what we can do is, so here we have base 9 and exponent x positive 5, and for this complete stuff we have the exponent 1 over 3x positive 6. So whenever we have two exponents like this, what we can do is we can multiply the two exponents. Then I'm getting 9 to the power x positive 5 times 1 over 3x positive 6. Okay, so on the right side we have 81. I'm going to write this 81 as a 9 square whole to the power of 1/4. So here we have a question. So why do we have to write this 81 as a 9 square? Even 81 is a power of 3, it can be as 3 to the 4th power. I am writing 81 as a 9 square because my aim is to get the same base on both sides. Already we have base 9 on the left side. So on the right side also, if I get base 9, I can equate the exponent and I can solve for x. So that's the reason I'm writing this 81 as a power of 9, that is 9 square. Okay, 9 to the power of, so now what I can do is I can multiply this stuff and this fraction 1 over 3x positive 6. So whenever I multiply a fraction by some value, so the value has to be multiplied by the numerator alone. So when I multiply this x positive 5 and 1, I'm getting x positive 5 over 3x positive 6 equals to 9 to the power of. So here we can multiply the two exponents because here the base is 9. We have the first exponent 2, and for this complete exponent, complete stuff, we have the exponent 1 over 4. So whenever we have two exponents like this, we can multiply the two exponents. When I multiply 2 and 1/4, I'm getting 2/4. Okay, now two terms are equal with the same base, 9. So the base on the left side is 9, the base on the right side is also 9. So whenever two terms are equal with the same base, what we can do is we can equate the exponents. Okay, let me do it on the next step. When I equate the exponents, I'm getting x positive 5 over 3x positive 6 equals to 2 over 4. So further, x positive 5 over 3x positive 6 equals to 2 over 4 can be simplified to 1/2. Okay, now to solve for x, what we can do is we can do cross multiplication. That is, the numerator over here has to be multiplied by this denominator, and the numerator over here has to be multiplied by this denominator. Then I'm getting 2 times x positive 5 equals to 1 times 3x positive 6. Okay, now I can distribute this 2 to this x and positive 5, then I'm getting 2x positive 10 equals to, then 1 can be distributed to this 3x and positive 6, and then I'm getting 3x positive 6. Okay, I'm trying to solve for x, but the variable x appears on both sides of the equation. So the variable x has to appear on only one side of the equation, so either on the left side or right side. So we have to get rid of the variable on one of the sides. Okay, let me get rid of the variable on the left side, so that when I subtract 2x from both sides to get rid of the variable, so I'll have a positive, the variable with positive sign on the right side. So I subtract 2x from both sides to get rid of the 2x on the left side. So positive 2x, negative 2x will cancel. I'm getting 10 equals to, when I combine this 3x, negative 2x, I'm just getting x. So positive 6. So here we get variable term with positive sign. That's the reason I got rid of this 2x on the left side. In case if I try to get rid of 3x on the right side, I may get a variable on the left side with negative sign. So it's not an issue. In that way also we can do. So usually we'll keep the variable with positive sign. So it will be easier for us to solve for it. Okay, now to solve for x, what I have to do is I have to get rid of this positive 6. For that I have to subtract 6 from both sides. When I do so, this positive 6, 96 will cancel out, and the simplification of this 10 negative 6 is 4 equals to x. So I have solved for x. The value of x in the given exponential equation is 4.